That's it. For where? What? UK or Ireland?
UK.
Yeah, and see, that's a different thing.
None.
And where are you applying? What?
Really?
Hang on, don't let... He would know if he has a conditional offer letter. Do you have any conditional offer letters? Now think carefully.
Not letter in email.
Or
He's
email.
not talking about letters.
Yeah, conditional offers.
You just are not in Yes.
You're doing UCAS and Ireland,
Yes.
covering your bases.
That day he got from UCC, but he asked for 2% statement. See, he doesn't remember.
No, because I gave them the personal statement.
Did you get an offer from them?
No, they just requested the personal.
Okay. So this is the difference. Those two are doing UCAS. You will need to check maybe with a science student going to...
They got from Belfast.
But that's still UCAS. Yeah. You need to ask maybe someone who's going to Galway, for example. Anyway, next topic. Let's see, what did I call it? The normal distribution.
The other one was normal.
The standard normal distribution.
So this one is the standard normal.
The one we did earlier today.
Yes, well,
The standard normal distribution.
that one is the normal.
The normal distribution.
No
Yeah.
standard.
No standard here. Okay. Now, you know that your table book will give you proportions on your histogram when the center is 0 and the standard deviation is 1. You know this. This is what we did earlier today. So for example, what is this area here at 0 to the left? 50%. Half. But what about if you had something like this where it was a height 160 centimeters and the standard deviation of the height is 10 centimeters? There is a technique. Do you know it? Ah, correct. So what did Judge Connell say?
Did he say you can do the definition?
No. This makes me more.
More worried. I have a question.
Sorry?
I have a question. Where were you for maths this morning? Yes, I know that. Any reason?
No. I just was working on this question.
Okay. This lesson might be difficult now because it continues on from the first lesson, okay? So you'll have to get the notes from someone. Right. Huh?
What's the video?
That too, yeah. Now, we saw a little bit of this at the end of the class. What did you say, KJ, we can do with the 160? It's like making it the 0. And we can make the standard deviation like it's 1. And there's a technique. Were you going to tell me what it was? Did you see this before?
Yeah, but I don't know.
There's something called the Z transform. And this is a way to change the histogram from non-standard to standard. Does anyone actually know the Greek letter for the average? This one is sigma for standard deviation. Does anyone know the one for the average?
X.
You can use X or the Greek letter mu. Or you can use X if you want. So it doesn't matter, we'll use X if you want. Because previously in math class we've been calling it X data, so we'll use X. Right, so Z transform, what you do is you take your X, whatever the X is, so for example, say the X is here, or the X is here, or whatever, and you make a Z as follows. X minus the average, actually you know what, no, I'll call it mu. Or, sorry, you can call it X bar, or we can call it mu. I think I'll... Fine. Okay, X bar. No, mu, because that's what's in the formula book. That would be better for you. X minus mu over sigma. Pen and paper, Karar?
Sorry?
Pen and paper?
Over minus p over 1.
Over sigma.
Oh, sigma.
What's the x?
Whatever number on the axis you want to convert into standard form.
So convert all the numbers.
Yeah, so I'll show you an example. Have you got this?
Yeah.
Right, so for example, let's say we have a histogram that looks like this. The average, let's see, well, okay, let's do 160 centimeters. And let's say here is 170 centimeters. And we would like the area to the left. And the standard deviation is, let's say, 5 centimeters. Ah, okay.
No,
If
it's
we-
too easy.
We'll just use 10. We'll keep our life easy. So what you do is you Z transform the numbers. So for example, to take the 160, well, let's take the 170 first. So you do 170 minus the average. What's the average? 160 divided by 10. So that becomes 1. Now, let's take this 160. 160 minus 160 over 10 becomes 0. So, wait, no, don't write just yet, I won't remove it. So what you've done is you've changed the problem, which is here not standard, into one which now is standard.
Standardized.
Well, look at you using your English, Mr. IELTS 7 or whatever you are. Yes, so you have standardized it, correct. So what is the area now? So if I said what is the probability that the person, their height will be less than 170 centimeters, the answer is, well, that's the same as the probability that Z is less than 1, which is the table book value for 1, which is 84%. So 84% of people will be less than 170 centimeters.
So in this there's nothing like less than or equals to.
You can put the equals in really if you want, I suppose, but it doesn't matter too much. I'll put in the equals. I can't remember what I did in the workbook. What did I do? Less than and equals? Or just,
Less than.
yeah, it doesn't really matter.
Which one does it get complicated?
Which one?
All these questions.
Okay, so write this one down, please. So this is our first example of standardizing. See, that's present continuous, right? And go on, give me past perfect continuous. I have been standardizing all morning. Okay, you got this one? Yeah. So let's look at kind of a more physics example, something you would see in engineering. Can I scroll down? Yeah. So an example would be manufacturing. So for example, whatever you're making, it has a hole printed into it, or we'll make it circular. So the radius here is 10 millimeters, okay? It's a hole in a wall, whatever, it's a connection. And you are making the plug that needs to fit into it. Now, of course, if the plug is too big, it won't go in. But likewise, we don't want it to be too small. So if the hole is 10 millimeters, what would you want the size to be for the connection that's going into it? Well, if you want to be exactly 10, of course, but you realize that because of the manufacturing process, some will be of different sizes. So what do you feel will be the sizes you can tolerate or accept?
9.9.
It's something like 9.9, 8, but maybe less than 8 would be too small. So for example, you could say, okay, it must be less than 10 millimeters, because or even 10 millimeters, but more than 10 millimeters definitely won't work. Why not? It won't fit in.
Yeah.
Just simply won't. But it could be a little bit smaller. Now you don't want it too small because then it will fall out. the connection. So maybe you can say, all right, so we can tolerate the size to be more than 9 millimeters, for example. Okay?
Yes.
So you collect your data of screws, so that there's a data of screw sizes. And when you look at your data, you realize, the average screw size is actually 9.5 millimeters, and the standard deviation is half a millimeter. Okay, so write this much down. So what I want to know is how many screws will be rejected, will not be a suitable size. Do you understand the question? Yeah? Can I go down to do it?
Yes.
Yeah. So let's draw the histogram. So what will be the center of the histogram?
9.5.
9.5. Can I scroll down?
Yes.
Yeah. Right, so here's our histogram of screws. The average is 9.5 millimeters, and the standard deviation is half a millimeter. And what is the desired sizes? We want anywhere from 9 to 10 millimeters. So we want this area. Make sense? Yeah. So what I want everybody to do is to standardize this problem. And what's the name of the process you use to standardize?
Standardization.
Yeah, but give me the noun.
Transform.
Which transformation? Z transformation, yes. Wait, don't go on to the area part just yet. Just get it up to this part. Right, did you all get that? You should have ended up with -1, 0, and 1. KJ? Did you get that? Yeah? Fahad?
Yep.
Yeah. Now, which area do we want?
1.1.
We do not. Which area do we want?
More than a.
Although I shaded this in here, really that's not what we want. We want actually this area because we want to know how many, did I say rejected or fit?
Rejected.
Yeah, so we actually want the black area. Although it doesn't really matter because if we get the blue area, then what do we do? 1 minus it, yeah. So which is actually easier to get, or what should we get first?
The middle.
Well, I think we'll get all the area to the left of 1. So what's that? How do you get that?
Checking the table.
5, 4,
1.
1. Then what do you need to do?
Get the.
Wait, no, don't write. I promise I won't scroll down, but just tell me what the process is here. So first I got 5, 1. That's the green area. Now what could I do next to try and get to the black area?
1 minus 1.
Yeah, if I do 1 minus this, what will that give me?
Black area.
No,
Which?
just
Just this one.
Yep.
Yeah, but there's 2 black areas. Yes,
We
okay.
can multiply by 2.
And then, yes, what you do is you take this answer and multiply it by 2. Then that gives us both black areas. So this will be, yeah.
At this stage, we have to make our own formulas
What do you mean?
like this.
Oh yeah, you have to think about it.
It's
Yeah.
not like
There's no trick.
there is no like two or there's not one answer?
Oh no, I could have gone, what I could have done is, you could have split it in half as well, and yeah, there's many things you could have done. 2, 1 minus, and then, okay, calculators, tell me what this is. It's going to be like 45% or something? No, 60, 40. Yeah, it's like 35 or something.
Thirty-one point seven.
So 32% of screws will not fit the size of the hole. Yeah? See what's happening here? Okay, I'll give you one to try, and then we'll look at something a little bit more difficult maybe. Can I scroll down?
Yeah.
Right, so we'll go back to height. So we'll say that the average height of a person is 160 centimeters, and the standard deviation we'll say is 10 centimeters, for example. And you have people, and whatever the story is, they're walking through a small door. Maybe it's an old building, I don't know. I can't make this interesting, so I won't pretend to. Right, so they're walking through, and the height of the door, we'll make it 145 centimeters high. Oh no, that's too short, is it? No.
Yeah.
Why not?
Sure.
Ah no, why not?
All doors should be bigger, not small.
No, it's a small door. Yeah. So my question is, listen, let's say we have in total 200 people, and they're walking through this door, and I want to know how many of those people do not need to bend down to go through the door. So most people will be too tall, and they'll have to bend down to go through the door. My question is, if you have 200 people, how many of them will not need to bend down, that can just walk straight through the door? Okay? So if you wrote that mathematically, what am I asking you mathematically? The probability that the height is less than 145. However, that's only a percentage. Then what do you do? That's it, yeah, okay. So see if you can get the answer. Before you get the answer, do you feel like this should be big or small? Have a guesstimate of the answer.
Small.
Small.
Yeah, I'd say 20 people or something like this. Yeah, we're talking about this level of people. All right, try it. See what you get. Can I borrow the book there while you're doing that? Let's see how difficult I make these. Okay, how did we get on? Did you get that finished?
Just almost.
1 sec? Okay. What you got?
It's actually 30.36.
Ah,
13 people.
13?
Yeah.
So we've guesstimated 20. Let's have a look at the calculation. So you want to know firstly what's the probability that the height will be less than 145. So if you look at your bell curve, the average is 160 and we are at 145. So when you standardize that, what's the average now? 0. And then what did you get for the Z? Minus 1.5. Yeah? So you want the probability of less than minus 1.5. So what did people do to calculate that? So Fahad, what did you do to get this area? How did you consider it?
I took the 1.5 value.
1.5 on the right,
Yeah.
and you took that.
Yeah.
So that's table book value of 1.5, yeah?
0.9332.
Yeah, and then what did you do to that?
I converted into percentage. 93 percentage.
Yeah.
Then I took the percentage of 200 people and minus that from 200.
Oh, that sounds like a slightly, yeah, okay. That gives you the right answer, but what I would have done here is I would have done 1 minus this to get this area, which will be the same as this area, yeah. So what is 1 minus phi of 1.5, please? KJ, make yourself useful. Tell me this number, please.
0.068.
So that is 6.8%.
668, so 6.68.
Okay, so 6.7% if I do one decimal place, yes? So 6.7% of 200, that is, what did you say? 13 people. 13.4.
If there's no 0.4 people.
No, but the question is, do we round up or do we round down?
Round down.
Well, here 0.4 round down, but what if it was 13.9?
Round
No.
up.
No, I still think round down. It's a bit like the sequence and series question, you know. You have 13 people, and then it's not quite one full person. So if you said 14, that'd be too many. If you said 13, that'd be enough. It's a bit complicated, but I feel like rounding down would be more suitable. Anyways, in this case we have to round down because of the 0.4 as well, if you want to think of it that way. But I feel like maybe it should always be a round down. Or anything really. Alright, next now, a little bit of notation. So in the last one, the average was 160 centimeters, and the standard deviation was 10 centimeters. No, I just want to give you some notation. So, height, if I write this height, this symbol here means behaves like or follows. And then if I write here n, 160, comma 10 squared. Now you don't need to worry about this notation, but it's just a way to express concisely and precisely that height in this question follows a bell curve whose center is 160 and whose standard deviation is 10. There's a square on the 10. Again, this is for some more advanced level of statistics that you'll do next year. So if I wrote something like this, height follows a normal distribution of 10, 4. What is the, worry about that next year. What is the average here? 10. And what's the standard deviation?
4.
No.
Or square.
No.
Root 4.
You need to make sure it's written in this form. 10, 2 squared. And this is the standard deviation, and this is the mean.
It was written like that to be square root.
Basically, yeah. You mean if it's written like this?
Yes.
Yeah. If the square is not there already. Now, I don't think they'll do it that way in the exam. In the exam, I'm hoping and expecting that they'll write it like this for the exam. But maybe not. Maybe not.
Maybe.
Yeah?
Maybe they mean.
No, it's possible. like I said, this is a new topic, so I haven't seen what this will look like in the exam for you. Not only that, they haven't given me any example questions for what it will be like in the exam. So I have no idea what this question will be like for you in the exam. Now, I have plenty of experience, so I have a good guess of what it will be like. Like, remember the example I did with the screw? It'll be, something like this. I'll give you another one now. What are you asking me?
They will give you example paper before the
No, they won't. They won't. They should give me one at the start of the year for new topics, but they haven't. Well, I mean, they have, but it doesn't include all the new topics. So anyways, that's a different matter. Okay, let me give you another physics one for you to try. So let me see. The manufacturing of screws, that's kind of one. Another physics type of question would be, what else? Like voltage. Okay, so if you have a constant voltage, this is what you want. You don't want your voltage to change a lot, because if the voltage is too big, what happens? In your house, when the voltage gets too high, what usually happens? If you plug something in and it causes a surge in the voltage, what happens in the house?
The fuse will go off.
The fuse goes off and the power usually is cut.
Yep.
So we say that the circuit is broken.
Yeah.
There's a circuit breaker that cuts off.
Yep.
So, for example, let's say that voltage is usually normally distributed with about 220 volts. However, what would you feel like the standard deviation is?
20, 50?
4 or 5.
20,
Nope.
50,
Oops. You're closer.
60?
I'd say 50. I'd say 50 is actually pretty good.
Yeah.
Because remember, voltage is AC in the house. And AC, the graph, remember, it goes up and down and up and down. So it actually varies a lot from 220. I think we said it can go up to, what's 220 multiplied by root 2?
311.
311, give me that, so 311, yeah. So yeah, Fahad, I think 50 is kind of a good value. So standard deviation the standard deviation is quite big for voltage, because voltage is, it changes a lot. So yes, the average voltage is 220, but is it always 220? No. It's actually always changing. So to make it a little bit easier, I'll leave it at 50 is good. No, 50 squared. Now,
50 is good for the voltage.
Standard deviation of the voltage.
I mean, like the real.
Realistically, I think it's about this in the power supply.
If you have that,
50.
you
Yeah.
can check
50
it.
volts.
Standard deviation.
No, we said 50.
50.
50 volts.
Yeah.
Normal, like fuse it.
I think so.
No, it's not mechanical. 50
I'm
means
not talking about math now. I'm talking about
Physics.
yeah.
Yeah. The power supply in the home is usually 220 volts, but it increases and decreases.
Okay, but it goes down to 50?
no.
It goes up to 311,
Okay.
and it goes down to, I don't know, about 110. Yeah.
That's what I'm saying. Right?
Yeah, 50 is the amount it varies by.
The amplitude.
Basically, well, half the amplitude, but I don't want to get too technical right now.
But it's in the switch,
Yeah.
like we have something, and so we have both, like
Yeah, yeah.
one. If you put something, like appliance that says 220,
Yeah.
on one side it's going to be 6.
Yeah,
So it cannot go like 110 or something like that.
yeah, what are you asking me? Do you have a question?
Yeah,
What?
it's like 220 can go to 110.
Yeah, temporarily,
Oh, okay.
but not permanently.
Why not permanent?
It's not even average at 110. It only temporarily is 110. If your appliance is 110, it requires an average of 110, not just that some of the time it's
Yeah.
110. If I said you need 2,000 calories a day, But most days I give you no calories, and then one day I give you 10,000. You know, this is not what you mean when you say an average of 2,000. You know,
I know.
you want it consistent 2,000. Anyway, what do you think would be a voltage at which the circuit would break? So it can go up to 311. So maybe the voltage cuts out in the house when it hits 350, for example. Or maybe even higher, maybe it has to be 400. I'm not sure. I'll say something like, we'll say something low like 320, that the circuit breaks at 325 volts. So if your voltage on the voltmeter hits 325, then the power cuts out for the house. Okay? So what I want to know now, basically, is if I plug in an appliance, what's the probability that the power will cut out? That the voltage will temporarily be too high. So as a probability, what am I saying? The probability that, what? Voltage,
Higher,
Should be less,
I want the probability that it will break the power supply.
greater.
greater than
Greater than
3.
325 is what I said. Okay. Calculate that probability for me using your tables here. I believe you needed a 1 minus.
Not 90%.
I believe you needed a 1 minus 97%. Don't you, Barry Allen?
It's not 97.
That's what it was said.
It's not even that.
Let's see. Who would you be most like? Barry Allen? Cisco? Yeah, who else have we got there?
2%.
No, you're kind of like Barry Allen. Like, you got the hairstyle too, kind of, and the dress sense as well. You kind of, that's the type of shirt I picture him wearing, you know.
2.2.
Oh, what do you want to do at university? Not CSI? Okay.
Well, flashless is power.
He did, didn't he? Oh, let's think of a way to get it back, don't you worry.
Somebody the spoiler is that Flash is going to die, but Wally is going to become the next Flash.
That's a possibility, because Wally was the name of one of the Flashes in the comic book, yeah. So your prediction is old Flash dead, new Flash Wally.
I thought Colin Farrell.
That's a bold prediction.
I thought Colin Farrell.
Oh, where?
Starbucks.
Nice. Which Starbucks?
Stephen Green.
Nice. Say hi.
No.
My name's Fahad. I'm sure you know my physics teacher, Stephen. Alright, we'll see if you're true. Is this your idea, or did you read somewhere? Well, it's not, it's a theory.
Yeah, this theory. But I think he would do, like, particular accelerator.
But everyone likes Barry Allen. I don't think many people like Wally. I don't know.
No, he's not going to die. He's going to, the two of them are going to be sweet.
Now you're talking crazy talk. I'm not listening to you. Not listening to you. That's crazy talk.
He's
Crazy
going to
talk.
be Kid Flash in the normal Flash.
1.79.
You're crazy talk. Crazy talk.
You know,
I was more interested in your Barry was going to die theory than this one. Sorry.
You know Young Justice, when there are two Flashes?
Oh no, no, stop talking, please. Stop talking. It's making me sad. Right, this average is 220, and then here is 325. So when we make this standard, this will be 0, and you said Fahad this will be
1 point, no.
What?
No.
What you saying?
1.79.
No.
give me a calculator.
Oh, bro.
325 minus 220 divided by 50. What did you say, Fahad?
1.79. No, 0.1.
What did you say?
2.
Because I said 2 to 5.
I think you're both wrong, amazingly. 325 minus 220 divided by 50 is 2.1. You're both wrong.
Oh, that's
Congratulations.
I said 2
Yeah,
because
that's
I used 2 to
2.1.
5.
No, that's
Okay.
2.1, that too is 2.1.
You're both wrong.
I'm
Congratulations.
giving the wrong answer.
Congratulations. So we want this area here.
Giving the
Approximately
final
my
answer.
answer.
So what do I need? 1, it'll be 1 minus by
2.1.
2.1.
Yeah.
It's the area to the left. So we'll do
That's
1 minus this area to get this
That's
one here.
1.79%.
What is it?
1.79%.
1.79%.
Yep.
Should we ignore him? He's being a bit crazy today.
Your answer is not complete for 7.
No, your answer is wrong. It said, read the question. It's English. It said less than.
Goodness, KJ!
It says,
Could you be more rude right now?
it says what's the probability?
Yes, that it will have less than. It's less.
Less.